Everyone, I am Poornima Bhat from CSE Data Science 4th Sem. Today I am going to explain about the mathematical induction in the discrete mathematics. In that introduction to induction, mathematical induction is a powerful proof technique used in the mathematics. It is primarily used to prove the statements about the natural numbers. The method consists of the two main steps, that is the base case and the inductive step. And then the basis of the induction, in that the base case establishes the truth of the statement for the initial value, usually n is equal to 1. The step is crucial as it serves as the function for the inductive processes, and then if the base case is not proven, the entire introduction processes will fails. And then the inductive hypothesis, assumes that the statement is true for some arbitrary natural number k, and then this step will allow us to build on the established truth to prove the next case. The assumption is crucial for demonstrating the validity of the inductive step. And then the inductive step, it involves the proving that if the statement is true for n is equal to k, it must also be true for n is equal to k, which is equal to 1. And then successfully completing the step documentations that the statement holds for all the natural numbers greater than the or equal to the base. And then in the next slide we can see that the example of the mathematical induction. A class example is proving the formula for the sum of the first n natural numbers. The formula states that the sum is n into n plus 1 divided by 2. By using the induction, we can verify that this formula holds true for all the natural numbers n, and then applying the base cases. For n is equal to 1, the sum is simply 1, and the formula gives that 1 into 1 plus 1 divided by 2. This confirms that the base case is holds. Establishing this foundation is essential for proceeding with the inductive step. And then the executing the inductive hypothesis. Assume that the formula holds for n is equal to k, thus the sum is k into 1 plus 1 k plus 1 divided by 2. It is important to clearly state this assumption to avoid the confusion later in the proof. Proving the inductive step, in that to show the formula holds for n is equal to k plus 1, we calculate the sum for 1 to the k plus 1, and then this can be expressed as the sum from 1 to k plus k into 1 k plus 1. Substituting the inductive hypothesis, we find that it simplifies to k plus 1 into k plus 2 divided by 2, confirming the formula. And then finally the conclusion of the proof. Since both the base case and the inductive step as prove, the statement is true for all the natural numbers. This technique showcases the elegance of the mathematical reasoning through the structured approaches. Mathematical induction is widely applicable in various fields of the mathematics and computer science. Importance of the mathematical induction. Mathematical induction is essential for proving the theorems in the number theory and the combinations. It provides a clear methodology for establishing the truth for the prepositions over the infinite steps. Understanding this technique is vital for anyone pursuing the advanced studies in the mathematics. And then this presentation provides the comprehensive overview of the mathematical induction, focusing on its principles, application and the significance. Thank you guys. Please do like and share. Thank you.